Now it's time to look at limits of trigonometric functions. Okay, so one of the things that we need to do is that we need to revise some of our trigonometric identities in order to solve some of the critical questions that will come when it comes to trigonometry, right? So when they trigonometry, actually three means three, right? Three. Tri means three, trigonometry. So tri means three. So the identities, there are common identities there. There are common ones that we need to look at. Some of the common ones that we have, we know that cos square of theta plus sine square of theta is equal to 1. This is one of them. There is also something like tan theta is equal to sine theta over cos theta. And some other minor trigonometric identities. The other trigonometric identities that you need to actually revise mostly. But then when we talk about trigonometric functions, right, they also have graphs. Okay, so let's say this is our x-axis, and then our y-axis. They also come in form of graph. So as a graph, um, we are going to talk about around the origin, because whatever they do over around this origin, right? That's what they do continuously. So when you're talking about trigonometric functions, the limits of them, right? Mostly we are concerned with their limit when they are approaching zero. So we are interested in what they tend to be at the origin. Okay, because continuously, whatever when they continue, they go in continuously infinitely. So they are sinusoid, I mean that they appear in this form, like snaky form, continuously. That's what they do. So infinitely we know that there is, so as infinity we know that they do that and they continuously do that. But we are focused on more interested in their limits when they are approaching zero. So limits of most of these functions will be as the variable, the independent variable approaches zero. So let's have that in mind. That's why we are going to be concerned much about this. Now, for the sine function, right? For the sine function, they appear like this. So what you have to look at is where the sine function starts from. The sine function starts exactly at the origin, right, and continues. So you can do the opposite way, right? Continuously like that, going sine. Now for the cos, right? The cos doesn't start from the origin, but it starts from the amplitude. Let's say the sine. So I'm saying that this graph is for the sine theta. Now for the cos, but yeah, this is the, let's call this one the A amplitude. For the cos, right? For the cos rather, the cos doesn't start from the origin. The cos rather starts from the amplitude going downward, and follow the same snaky wave infinitely. So if you go to this side, it goes like this, infinitely like this, right? This is for the cos function. So what you have to do, your eyes, you have to go and look at the origin, right? And look at what's happening here. So this, the cos starts from the amplitude. This is a cos theta. This is a cos graph because it's the cos starts from what? The amplitude value. But if it is sine will actually exactly start from the what? The origin. Basically, that's the basic form of how you can look at uh, cos functions. For the tan functions, as for them, they have asymptotes mostly, so they appear in snaky way like this going forward infinitely, and they have asymptotes everywhere, right? But then we are most interested in the two most basic one, cos and sine. Okay, so that's how they look in graph. So and I say mostly they were appearing as they approach what? Zero. So now if you are focusing on, so let me say limit as x approaches zero of this particular function sine theta. See, know these common values, especially at zero. Sine of zero is equal to zero. Sine cos of zero is equal to 1. You have to know these two very well. It's very good to know. It's very fundamental to know that this is what they do, right? The cos sine of zero is zero. Sine cos of zero is what? Cos of zero is 1. So have this in mind. So we are going to still use the method that we learned first, right? Which is when you are going to find the limit of a function, right? Do direct substitution. So direct substitution, meaning that there is going to be, let me clean this in, it should be theta. It shouldn't be theta, right? It shouldn't be theta actually. It should be x. Now, so when we put x inside, we are going to have sine zero. And what did we say sine zero is? Sine zero is zero. So this is the limit value. Yeah, that's mostly what happens. But then and then the cos, what of cos? Limit as x approaches zero for cos of x. So it means that if we do direct substitution, we are going to have one. That's what happens mostly. But then there are some of the functions, especially with the sine function, sine, that um you may have something like this. We have a function, a special type of a sine function that we call the sinc function. What do you mean by the sinc function? The sinc function is a rational function, trigonometric functions. This is how it comes. Let's say sine of x over x. This is a sinc function. We call it sinc function. So what you have to do, you have to make sure that whatever is here, right, should be the same as the denominator. If you have this for this particular sine function, you call it a sinc function. Basically, that's how you have to make sure that whatever is in front of the sign is the same as the denominator. Then you have a sinc function. So sinc function is most of the questions asked around that trigonometry, or how do you call it? Um, Around that particular value. So look, when we have the limit as x approaches zero of sine x over x, the answer is going to be 1. This is the only case that you can have a sign of something like this to be. So you see, when you put 0 inside this one, you're going to have 0, right? But then for a sinc function, when you do it like this, right, the result is going to be 1. So this is one practical thing that you need to keep in mind. Always, before it can work, you need to make sure that whatever is in front here is the same as whatever is at the bottom here. That's how to find the limit of trigonometric functions, especially when it comes to sine function. So mostly the focus will be transforming everything to the sine function and be able to find the limit. So this, we are going to use this sinc function. So keep this in mind. We have cos 0 is equal cos of 0, not cos of theta. Cos of 0 is equal to 1. Sine of 0 is equal to 1. But the sine can only become this thing, how do you call it? 1 if the limit as x approaches 0 is of this is equal to 1. This is another one that you need to add to your 2. Okay, this is another one that you need to add to your 2. You know the trigonometric identities, right? Revise the trigonometric identities in order to continue with this one. Yes. So these are the basic things that we are going to use to solve a lot of questions around sine of trigonometric functions. For example, when I say we have to find limit as s approaches 0 of sine of 2x over x, you will see that when you put direct substitution, you put 0 inside here, the numerator, if you put, because it's a trigonometric function, it's a rational function, right? When you put the x at the denominator to do direct substitution, what will happen is that the denominator will be 0, and then it will make us not to use the first method. Okay, you remember what we did in the previous video? Right? I think last 2 videos we solved a lot of questions on that. If you want to do direct substitution, put the value. If the thing is a fraction, if the function is a fraction, put the value there under the denominator first to check if it will be equal to 0 or not. If it is equal to 0, then that method will not work. Direct substitution will not work. So you have to proceed with the other one. But you don't have to proceed with simplification or all that. Basically, for trigonometric function, you have to know some of the basic things like the one that I just showed you over here. That you have to know these 3, right? So basically, you have to work on that. And over here, we need to make sure that the value that we have here, right, should be the same as the denominator before you can use that particular method. So to do that, basically, how do I make the down also become 2? I need to multiply the bottom by 2, right? So what I'm going to do is the limit as x approaches 0 of, so I'm going to sine 2x, right, over x. But because I want to multiply the bottom by 2, I'll bring this fraction. Remember this in basic school, right? 4 over 5 is the same as 8 over 10. How do I do that? 4 over 5, I multiply the top by 2 and the denominator by 2. Whatever factor you are using to augment it, make sure that it is the same for both numerators, so that when you cancel back, you get back your result. So we are just magnifying the distance. So you have 8 over 10. That's what I did to get here. That's what you also do over here. At the end of the day, let me clean this side so that we can solve this. At the end of the day, what's going to happen is that we will not have we will now have this in this form, limit. So the denominator will become 2 sine of 2x over 2x, right? Because we introduce this factor, which is this one. Remember, it's x approaches 0. But when we do that, right, this is a constant. So the constant for limit, according to limit rules, right, the constant can go out, become 2 lim of x approaches 0 of sine 2x over 2x. Now, this and this are the same. If since this and this are the same, what we are going to have, remember, is going to be like the sinc function. The sinc function, which is this, it should be equal to 1. So if it is equal to 1, then it means that we just have 2 times 1. So the answer is 2. This is the limit for this particular question, right? So that was the introduction to the concept in this particular um, session. In the next session, we will actually solve more questions as how we did in the previous session. Make sure you follow and solve the questions alongside and try more examples, because we are building concepts in trigonometry so that every engineering student can have the basic calculus in order to thrive through their university life, right? So these things are very basic that if you have done learned calculus, these are the important ones you need to hold. At least you need to know them no matter what before moving forward. So these basic ones should be in your basic tool that you put in your pocket and then master them. So we will solve more questions of around this in the next session. So subscribe and stay with us in order to get more of these concepts going forward. See you in the next session.